All right. Welcome back to the drive-thru, everybody. All right. Special North Korean edition of the drive-thru. Sponsored as always by the deli. Hungry? Stop by the deli and everyone can have the exact same sandwich. Oh man, my family's gonna get killed for that one. Okay. We are on to 5-7, which is proving that figures are special quadrilaterals. Okay? And look, if I wrote out every word that was in the book, this lesson would probably take 40 minutes, and none of you would watch it. So we're going to utilize pictures for this, and I'm going to give you examples of what the theorems, or not the theorems, the reasons will look like, but I'm not going to write them all out, okay? So, what are we doing? Well, we are proving things to be rectangles, quites, rhombi, squares, and isosceles trapezoids. Sorry, Hank. Okay. So, what you might want to remember first is how many ways there are to prove each one of these things, because I think you'll be able to figure them out, okay? So, there are 3 ways to prove that something is a quadrilateral is a rectangle, okay? So, if it is a quadrilateral with right angles, then it is a rectangle. So here's how you write that in a proof. If quad with 4 right angles, then rectangle. So yes, you are going to have to write out those words in your proof. What I'm not going to do is I'm not going to write that out for every one today, I don't think. Okay, so I want you to pay close attention to the second word in each of these statements. That one says quad. The next 2 are going to say parallelogram, okay? So, here, if AE is congruent to BS, and you know that this thing is a parallelogram, then it's a rectangle. So, if a parallelogram has congruent diagonals, oh gosh, then it's a rectangle. You have to also prove that it's a parallelogram first. Otherwise, it could be an isosceles trapezoid. And then the other way is, if it's a parallelogram with 1 right angle, if P-gram has, has 1 right angle, then rectangle. Your English teachers are going to kill me. We're just randomly leaving out like prepositions, but it's okay. I'm just trying to save you a little time. So that's what we're doing today, and this is going to be hard. Okay, wait till I get to the end of this, and I totally blow your mind with the bad picture problems. All right, here we go. There are 2 ways to prove that something is a kite. One is just a definition of a kite. So, if a quadrilateral has 2 pairs, has exactly two pairs of consecutive congruent sides, then it's a kite. That's just the definition. I'm not going to write that out because you already know it. Okay? The second one says, if one diagonal, just one, just bear with me on that. If one diagonal is the perpendicular bisector of the other, then if a quad, it's got to be a quadrilateral, has one diagonal, that's the second time I've done that, that is the perpendicular bisector of the other, then kiite. And I think we want has exactly one, but I don't need you to say that, but I don't want to be wrong. We don't want our kites to be rhombuses. Just so you know, the book has a differing definition than we do. But that also means that I won't be asking a lot of questions about kites, especially proofs. More algebra type questions. Okay? All right, moving on. How to prove that a quadrilateral is a rhombus. There are three ways. One is the definition of a rhombus. So if a quadrilateral has four congruent sides, then it must be a rhombus. Just so you know, you do not have to prove that that's a parallelogram, but sorry, okay? The second one would be if a diagonal of a parallelogram, so you got to know that it's a parallelogram. If a diagonal of a parallelogram bisects an angle, then it's a rhombus. Notice I'm not using pictures for rhombus. Okay? And finally, and this isn't going to look like a great picture because of the widescreen, although that's not bad. If the diagonals are perpendicular bisectors of each other, notice the difference between a rhombus and a kite. Then it's a rhombus, okay? And finally, luckily, there's only one way to prove that something's a square. You've got to prove that it's a rhombus and a rectangle. That's it. Okay? You got to prove that it's a rhombus and a rectangle. And that's the definition of a square. Okay? So you're going to find the book will give you questions like this. They'll say, what kind of shape is that? So what they do is they draw you something that looks like a square, but that is not a square. It's also not a rectangle. If it was a square or a rectangle, the picture would look like this. Okay? So, that is just a parallelogram. Okay? But what if it looked like this? By the way, this is a parallelogram. All they need to do is change the picture so they can make it look exactly the same. Again, starting to look exactly the same. Now what is it? Well, judging by last picture, it's still a parallelogram, but now we have more information. It's a parallelogram that has two sides that are consecutive, are congruent. So what is it? That's a rhombus. Stay tuned tomorrow for our Always, Sometimes, Never video.